In this question, we're asked to find the time constant of a circuit that has not one capacitor and one resistor, but a network of capacitors and resistors. So the trick is to simplify the network, to represent it using something like a Thevenin equivalent circuit. So you want the equivalent capacitance for this network of capacitors in the capacitor bank, and you want the equivalent resistance for this. So the time constant is really just the product of R times C. But which R? You'll want the Thevenin equivalent of all of these. And which C? Well, you'll want the equivalent of these capacitances. So if we look at these capacitors first, you have these two in series and these two in series, so we can calculate the equivalent of each of these. So the 12 and the 6 in series will give us 4 nanofarad, and the 5 and 9 in series will give me 3.2 nanofarad. And then because the equivalent of these and these are now in parallel, then you can add the two to find the equivalent capacitance of 7.2. So what we can then do is remove this bank completely. If we consider this a load, we can remove the load as if we were trying to find a Thevenin equivalent resistance. So you can remove the load, and we can find V Thevenin or E Thevenin if we wanted, but we don't. All we need now is the time constant. So we need to find the equivalent resistance. And to do that, we need to short circuit the voltage source. So we replace the voltage source with a short circuit. That has the effect of eliminating these two resistors. So even though we've got 3 kilo ohms in series, because they're in parallel with a short circuit or in parallel with 0 ohms, effectively these disappear. So another way of saying is that the parallel equivalent is 0. So looking this way, R Thevenin looks like it's just 9 kilo ohms. So now we know R Thevenin, and we know the equivalent capacitance, 7.2. We can find the time constant by simply multiplying those two. So we multiply the 9,000 by 7.2, and that gives us 64.8 microseconds. So the trick for questions like this is to find the equivalent capacitance if you have a bank of capacitors, and try to find the equivalent Thevenin resistance if you have a network of resistors. And to do that, you need to short circuit a voltage source and open circuit any current sources. So I hope you found that helpful.